So here's what we have. We're going to say instead of a, we'll get crazy here. Instead of a riverboat, it'll be a football, as in a soccer ball, as you Americans say. So soccer ball goes like this. I'm going to give you delta P. So it goes over here. This is a pretty tough problem. Delta P is, let's say they kick this soccer ball 35 meters, and it makes an angle of 22 degrees with the sidelines. That's what I mean here, 22 degrees. So a player kicks it to his buddy or enemy, whatever, and let's say it takes, I'm trying to think of what would be reasonable, 35 meters. Let's say it takes, I don't know, 4.5 seconds. I think that'll be a pretty fast kick. So there's all the information. We're going to calculate Vx and Vy with what we have there. So let's look at the equations real quick. To calculate Vx, here's the equation. We need, what two things do we need to get Vx? Time and what kind of displacement though? X displacement. So I gave you something else. This is a new type of value. Well, I wouldn't say it's actually new. I mean, we've talked about displacement. It's a straight line from start to end. But this is different than X displacement. X displacement is like how far downfield you go. So in soccer, there's a rule called offsides. You got the refs running on the side with this flag to figure out how far downfield the ball goes. And that is, they only care about how far downfield it goes. They don't care how far the ball goes up and down here if you're an offsides ref. I don't even know what you call that person. So this is what delta X is. Delta X is how far sideways it goes. So X displacement is how far it moves along the X axis. Whereas regular displacement is how far it is from start to end. So you probably have a guess then. Who do you think that guy is? Kaboom. Very good. Delta Y. And so we are going to be visited by our old friend. What do you think? Are we going to use, to get delta X, are we going to use Pythagorean theorem or SOHCAHTOA? SOHCAHTOA. I'm going to show you a shortcut equation that'll make things a little faster. Now you can use regular SOHCAHTOA if you want, but for real, if you get good with this, it's going to save you some time. Even on like the SAT, I'd say. So here's the shortcut equation. Maybe, I think we already wrote them down at one point, but they're buried in your notes. It's a good idea to write it down again if you haven't. To get an adjacent side, to calculate an adjacent side of a triangle, what's hype? Hypotenuse. Not like, never mind. Cosine theta. To get opposite, you take hypotenuse sine theta. Adjacent equals hypotenuse cosine theta. Opposite equals hypotenuse sine theta. So let's look at what we have. Delta X, is that compared to the 22 here, is delta X adjacent to the 22 or is it opposite from the 22? Adjacent. Okay. So we'll use the adjacent equation. It'll be hypotenuse times cosine theta. So that is our adjacent. Adjacent equals hypotenuse cosine theta. What's our hypotenuse? 35. All right, I think you got it. 35 cosine 22. So this will give us delta X. Oh yeah. Blanket here. I got 32.5. check ourselves. Two things. First, the unit is m. What about the sign? What do you think? Is delta x plus or minus? Plus. So it looks like we could have missed that. Okay, now we're ready to find Vx. But you know what? While we're at it, let's find the opposite side. What's the only difference? Well, now the main difference is sign. So we're going to end up typing the same thing. To get delta y, looks pretty similar. So delta y is going to be hypotenuse, which is still 35, sine of the angle, and the angle is still 22. So 35 sine 22. Same as these. Positive 13.1 meters. Now these are important numbers. I'm going to put a dotted line around them. All right. So why the heck did we get those again? What are we trying to calculate for this problem? What are they even asking us for? Velocities, Vx and Vy. So now we have everything we need. We have delta x, we have delta y, and time was given to us originally. If we go back to the equations, just plug it in. So Vx is whatever we got over the time, Vy is that over time. Yeah, what's up? Oh yeah, you were gone for that. No problem. I'm going to write them down here too. So we're going to solve it. I'm going to write them down there, so if you didn't get them fully, we can write them here. So we're going to solve for them here. So this was the first one. Vx is delta x over t, and Vy is delta y over t. Okay, I'm zoning out. So 32.5. I don't want to keep throwing up. I don't want to keep scrolling up because I'll throw people off. What's the time? 4.5. 4.5. Thank you. And then for Vy, what was? Oh, that was 13.1. I don't want to keep throwing up. I don't know why I did this one first, but 7.2. What was after the 2 though? It's 2.205.
Oh, it's just 2 repeated.
Gotcha. Thank you. And I'm using the. .22 meters per second. It's positive because we're moving right. And Vy will be losing my mind. 2.91. And that is also positive. Okay. I think we'll do